Hey, what's up, everybody? Welcome to Working Group. Actually, it's been rebranded, right, to Office Hours. Usually Big J is gonna be Javier is gonna be running these, but for today, just for today, he had other obligations, so I'm gonna be running it if that's all right. Just want to keep in mind that there is a doc that is, that you can fill out with agenda items. I'm gonna link it in the chat, and I'll give you maybe like a minute to fill something out. Okay. And while you, how about some tunes while you fill stuff out? I'll give you 1 minute.
Nice. I like this new format.
Just waiting for the DMCA on the YouTube channel.
Is there a timeline for fair use?
I don't think they care. I think they just immediately automated give you that.
Is this the same doc from? Oh no, this is a new doc.
Different doc. Sorry, I always want to give credit to hardworking recording artists. So in the chat, those are the artists and the album that we're listening to right now. Okay. I think we're gonna start. If that's okay with everyone. Y'all can see my screen. Here's the agenda for today. We're gonna start recording, and I do have an architecture overview of KPAC that I wanted to share. But please, if there are any other items people want to discuss, we can go through with it. Sound good? Okay, so KPAC, I have a little presentation here. It's going to be very high level. So KPAC is an open source project that is basically another platform, right? If you think about what a platform is, it's basically going to be something that uses our life cycle to do, I don't know, container type things. But first of all, let's just talk about, I don't know what page everyone else is on. Let's just get on the same page, right? This is a Kubernetes cluster, right? In the very smallest form, this is what it normally looks like. You have an API etcd and a worker, and you basically usually talk through it through kubectl. You can use other methods, right? But usually use kubectl to talk to it. The etcd is where all your metadata is stored. API does API things, and the worker is where your container workflows get run, right? If you know Kubernetes is basically a big reconciliation loop. You give it your desired state through the API, stores it in etcd, and then it will basically make as many containers, as many resources as it needs to reach that state. Okay, so KPAC in its smallest form is basically just one controller. For whittling it down, it's not entirely accurate, but it's basically just one controller container, right? The reason we have this is because when you're sending desired state to the API through kubectl, you're sending in YAML, which is usually pre-written, right? But for KPAC, we want to make it a little bit more dynamic. We don't know all the fields ahead of time. So we basically need our brain, well, Kpack's brain, to be basically be a container. And the way this thing works is it talks to the API. Okay, so that's just what you need to know there. So if I haven't made it clear yet, what Kpack does is it takes source code, doesn't have to be from GitHub, but let's just use GitHub, takes source code, builds a container out of it with using Buildpacks, and it dumps it in a registry, right? If you can just think of it as pack in the cloud, if that makes things a little bit easier. And the way it does that is by basically making these build containers. That's official terminology. And these are a little bit more ephemeral, right? The controller is going to be there your entire span of your install, but the build controllers are going to be there, as long as the build happens, right? And there's a lot going on in here, but basically for the most part, you can think about it. Hey, I'm downloading my source code from somewhere. I'm running through lifecycle stages. Export will shuttle all my information out to the registry. And so just a little bit of an architectural thing here, right? Because Kubernetes is more about desired state, it is more declarative than imperative, right? It's a little tricky how you have to get these things to happen in sequence, right? Like, let's say with Pack, you can individually say, hey, I'm making this container and take the outputs of this to the next container, and right. You can do things like this, but because we can only really make one container, what Kpack is doing is making a build container, and then each of these lifecycle phases are implemented as discrete init containers, right? That's how it's trying to get sequential behavior happening, basically. But for the most part, if you can just get wrap your mind around that, that's really what's happening. The completion, which is the actual container itself, this is the actual thing, really doesn't do too much, right? It's really just there to satisfy the container spec, right? But this is how it normally works. Cool. Okay. The other big component here is KP. So KP is honestly, to be honest, it's really just supposed to be like something you pair up with kubectl, right? Like you could do everything KP could do. It's basically just a way to interact with the API to talk to your custom objects. But we made KP to be a little bit simpler or a little bit more Kpack specific, right? So basically you can do nice little helper methods. So that's the intent there. But truth be told, you could use either or for anything. That's just all that does there. And lastly, of course, it also does rebase as well. In fact, that's one of the biggest value propositions, is being able to do rebase automatically whenever a new stack is updated and things like that, right? And as you might imagine, the rebase pod is very simple. It's basically just the init container, and then I guess just for parity, or just to make things as least complicated as ever, you have this completion container, which again doesn't do as much as you might think. Okay, and lastly, just wanted to talk about this itself, right? The image itself, right? Which we know as the builder image. In Kpack, it's a little bit more, it's just a little bit different, right? A builder image is made of usually the same things, but the metadata is just is just structured in a different way. You normally have a secret, right? And this is a Kubernetes, these are Kubernetes objects that I'm pointing to. You have a secret that's stored somewhere that the builder has access to, which it uses to talk to your registry and GitHub and whatnot. You have a stack, a cluster stack, right? Which is basically just the metadata object around your stack, right? You have cluster store, which is again a metadata object around basically your build packs, right? But these all work to make this metadata object of a builder, which corresponds to a real container image that Kpack builds for you and puts in the registry, which it uses to build all these build pods. Okay, it's sorry if that description is a little clumsy, but a lot of the actual difficulty of KPack is really around the metadata. So I tried to distill it to what's a real thing and what's not, like something that's stored in etcd or whatnot. And that's all I have for you. I was wondering if you have some questions.
I definitely have some questions, especially around this last section here. So I guess maybe you could elaborate a little bit more about the idea of builders, right? Are we saying that KPack does not have the support for me to be able to provide it, like let's say the Heroku builder or the Google builder, Paketo, so forth? Given that it has these like pre-built notions and it creates like this ephemeral ad hoc builder, or am I completely missing the point here?
No, it's a good question. You can use your provided builder, right? But you have to register it as a Kubernetes object, basically, right?
I see.
There's a Kubernetes object called a builder. There's a kind. If you know Kubernetes,
Right.
there's kinds of objects. So you have to, no matter what, you have to make the YAML that says this is my builder, and then it points to this container image XY. You can make it your own. You can make these your own, like out of these custom objects. But your question was, can I use a? Honestly, you'd probably want to do it like this, right? That way you have insights into like the discrete pieces of a builder, right? Like what the stack is and what the store is and whatnot. But theoretically,
Well, I guess that's what's throwing me off,
okay,
right? Like the
gotcha.
cluster stack and the cluster store, like I'm trying to relate those to the things that, obviously I see in Pack, and those those don't exist in that
Yeah.
context, right? And so like, how do those tie in to me running a build operation?
Okay. All right. Maybe, okay. I'll try my best here, right? Like the reason you want these objects is so that Kubernetes can give you these reconciliation rules, right? Like let's say you update a Buildpack, right, which updates this metadata in a cluster store. Kubernetes knows, oh, my cluster store is associated with a builder. I'm going to recreate my builder. Because I've recreated my builder, all my build pods that have been built as a particular app into a container image needs to be rebuilt, right? That's why you want all these metadata objects, right? Because Pack, for instance, doesn't have all these reconciliation loops, you don't need to register these other abstractions. But it's still the same thing. Like literally, we are talking about a run image, a build image, some build packs, right? At the end of the day.
Then that builder object at the top, right? Is that built, like maybe you could show it, I don't know if you have one handy, like the definition of that builder, like is that builder then pointing to things that are in the cluster stack and the build packs that are in the cluster store as references, or are they completely like, two separate different entities?
I will absolutely, the tutorial is pretty good. I will try my best. So this is a builder definition, right? Like I said, it has a service account and then a stack, which is another kind of object, and a store, which is another kind of object. And I didn't talk about this in the whatever the slides, but you can order the build packs that they show up in, right? So these other things are things that also have to be made, right? And these stacks are pointers to images, right, that exist on repos, right?
Okay.
Does that show you beneath the curtain a little bit?
Yeah, totally. I have more questions. I don't know if we want to go down this rabbit hole, but if other people have any more high-level questions, maybe I could.
Yeah, if we omit an order, can the build image already have build packs on it? And will it execute through those? I know you wouldn't get the benefits of getting build pack updates like individually, but could you use an existing builder and create the metadata around it and still have it execute without too much ceremony?
That's a good question. I'll be honest with you there. I have no idea. I've never tried to do that. It's just sort of was always explicit. I've always explicitly defined it.
Yeah, I think that was kind of maybe in line with my question as well, right? Like that store seems to be maybe required and it points to a default store that I'm assuming the default store then has all these build packs in it. And like,
Yes.
I guess my question is like, why?
Why have this?
Yeah, I guess like why have the image tag on the builder if I'm still defining like the entire composition of
Oh,
all the
okay.
bits somewhere, like
Okay.
somewhere else?
Well, this abstraction is very useful, right? Because you could
Yeah.
update a build pack, right? And then Kubernetes knows my cluster store has updated, which means my builder has updated, which means that every image that's used this thing can be updated as well, right? That's my best attempt at why this abstraction is nice to have, right?
Yeah, I definitely get that part, but I guess maybe
Yeah.
the tag there in the builder, is that saying where I'm gonna be pulling an image from that I've denoted all these things from, or is that where it's gonna be stored? Like
This
maybe,
is the KPack can build an image builder for you. So this is where it's going to be stored.
I see, okay.
You can, yeah, it can create it for you.
Oh, that's cool. I didn't realize it could create a builder. So we could use KPack as like a CI to create the Heroku Buildpacks builder, for instance, even if we don't have any images that are potentially using that within that same cluster, we could still have it create a builder image for us.
Yeah.
Is there a tool or a mechanism for doing the opposite? Or would it even be supported, like I said, going back to my example
Yeah.
of using the pre-existing Heroku builder and saying like, hey, create all these objects from this image tag?
You know, I want to say yes. I want to say yes, but I can't say it with certainty. Sorry. This was supposed to be an intro. You kids are asking hardball
We're going
questions.
advanced. We're going all the way. Okay. Sorry. I apologize.
No, it's all good. No, it's all good. Honestly, I want to say yes, but I just honestly I just can't recall yet. The normal default path is to create your own builder though. And you know, you could reference all the same things, right? All the same things in the Heroku builder, right? And theoretically, it's essentially the same, right?
Yep.
Okay, yeah, you know, I don't want to belabor this. Do we have any other thoughts, questions?
Thanks for the overview. It's changed a lot since I last looked at it.
Do you know, I guess what's next for KPack as far as like any features or anything like that, or is it like stable in a good state right now where it's just functional?
Here's what I'll say I do know, right? You know, I do know that they were working very hard to get to this 1.0 release where things were, you know, basically whatever feature set that they had went in. And, you know, they did 1.1 after that. And I think things are very much settled at this point, right? There isn't like a big rush to accomplish another milestone, so to speak. So I don't know what's on next on deck, but that's, you know, if you can think of like your product cycle, that's sort of the spot that they're in right now.
Similar, do you know if KPack is going to support Project Toml?
You asking me? Oh,
Sure.
no, I definitely don't know that. I definitely don't know that.
I assume that means you don't work on KPack?
No, no, okay.
From the way you're talking about.
Okay, maybe I should preface this. Yes, I used to be on the team. I haven't been in a while, and No, you're asking again hardball questions here.
Yeah, I guess I'm also interested in roadmap stuff of just like if KPack is looking at stuff like stack packs and seeing that fit in the flow. But that's probably related to even like some of the Project Toml stuff.
It didn't come up. Stack packs in particular hasn't come up, but it might. It might. It's open. Please feel free to petition for it if that's desired. All right. Well, by the power vested in me as host of Office Hours, I think I'm going to call this one. All right. I appreciate everyone for coming.
Thank you.
Yeah, Anthony.
Thank you, Anthony.
Yeah. Thanks for hitting the record button as well. Yeah.